Hi, so this is the first of a series of videos on how to implement a stack using the linked list concept. And we'll start with the node. And the reason for that is because the node is a fundamental, very fundamental building block of a linked list, right? And also, just to keep things simple for now, we will only focus on the part that's necessary to chain all the nodes up together. So we really just worry about the next pointer for now. We will add the component so that data can be stored at a later time. Now, if all we're concerned about is the next pointer, then it's fairly straightforward. So I'm defining a class node here, and in the initializer, I'm just going to create a single attribute. Just going to call it next. Now I have to set it to something, and at this point, I'm just initializing a node, an individual node. I really don't know what the next pointer, what the next node is. Therefore, I'm just going to set the next attribute to none, right? That's a sensible default. And now in the thunderstring method, it might not be immediately obviously what we can print out is just a node that has really nothing. It would be useful, and I'll show you in a bit why, that will print out the ID of the node itself and the ID of the next node that it points to. Okay, so that's what I'm going to do now. So let me just run this, and you'll see, well, I instantiated two nodes here, node 1 and node 2. I print out their ID, the node's ID itself, and also the node that it points to next. So now here is a kind of an interesting observation that I thought we set the dot next to none, right? So it should be pointing to none. So what is this ID? Well, as it turns out, it is the ID of none, because none is an actual object in Python. So if we add another line that just prints out the ID of none, and you run that, we see that the ID of none is this number, which appears in both of our nodes as the next pointer. So in order to make things a little more clear, I am actually going to print out the word none if the self.next is none. Otherwise, I'm going to actually print out the hex ID. So this is just so that it's more obvious that, you know, when next is pointing to none or another actual node. Now, so this is the picture with two nodes, right? We have node 1 pointing to a node, node 2 pointing to a node. Now, they are two individual nodes. They do not yet form a linked list. So our next job is to link them up, right? And we know the picture that we want when we do that is that we want the next pointer of node 1 to point to node 2. And it's fairly straightforward to do that in Python, and that is just assign node 2 to the next pointer of node 1. Right? Remember, when the assignment operator, all that is doing is it changes what a name or an attribute references, and so the next pointer in this case would then the node 1 dot next pointer in this case would reference node 2. So let's see that we actually run it, and here it is. Well, actually, I probably should print out node 1 and node 2. So we see this is the original node 1 and node 2. And after I assign node 2 to node 1 dot next, node 1 dot next, this ID is the same as the ID of node 2. And yeah, this is why I actually print out the ID here, so that we know we link up the two nodes correctly. So next, I'm going to ask you to try this yourself. So just create another node and have node2.next point to the new node, node3, and then just print out all the nodes to check all of their IDs and all of their next pointer to make sure they all match your expectations. So pause the video and give this a try. I am not going to show the answer because, well, it should be hopefully fairly straightforward. So moving on. Now, so we can see how we can build a linked list with the node class we just built, right? So, and so when the client code, the code that uses the linked list, when they want to add something, insert something to the linked list, should the client code have to kind of explicitly or manually chain up the nodes one by one by themselves, right? It's actually not reasonable to expect them to know about nodes and how to chain them up, because that would be almost like, if when we have to use the Python list, which is partially implemented like a linked list that we just described, we would have to know how internally the Python linked list work before we can use it, which is actually not as straightforward. And thankfully, we didn't need to do that in order to make use of list. So so what we then really have to do is that we want to hide all the internal implementation of a linked list from the client code. And another word for hide is encapsulate. So data encapsulation is going to be, it's a concept that we keep talking about, and it's something very important in programming in general, that we don't want the user or the client code of the class that we write to know how we internally implement our class. So we don't want to expose the nodes, the node next pointer, and all those details to our client code. And instead, we should provide some methods like, insert or append, etc., to kind of add things to the linked list, which I mean we've seen many, because we use Python list so many times. We've seen how Python list does it, and we're going to do something very similar.